Hello everyone, my name is Rohit Singhal and we were discussing about the topic redox reactions. In the previous lectures, we have discussed what is redox reactions, we have separately deal with the oxidation and reduction thing. Then we have discussed redox reaction on the basis of electron transfer process. Then we have discussed two more things other than oxidation and reduction, that is oxidizing agent and reducing agent. We have told that oxidation reaction and reduction reaction goes simultaneously with each other, and this complete reaction is called a complete cell reaction. For the star simplicity, what we do, this complete cell reaction we divide into two equal halves, and what one we call as oxidation half cell and another is called reduction half cell. This does not are the two separate reactions, but for the star simplicity we read the oxidation part separately, read the reduction part separately, and then we will combine, that calls a complete cell reaction. Then we will discuss two terms, that is oxidizing agent and reducing agent. What oxidizing agent and reducing agents are, that for an element to be get oxidized, there should be something or driving force on agent to let it oxidize. For example, if sodium is losing electrons, there should be someone to gain electrons. So, that acceptor of electrons, that is chlorine, if in case of NaCl, this is known as the acceptor of electron, that means oxidizing agent, helping sodium to get oxidized. Similarly, sodium is giving electrons to chlorine, that means sodium is helping chlorine to get reduced, that means sodium is donor of electrons and helping chlorine to reduce, that means it is an reducing agent. Okay. So, later then we discuss about the competitiveness between the electron transfer. This competitiveness I have discussed about zinc, copper and silver solution, that means I have said that zinc has the more tendency to go into the or to get oxidized as compared to copper and silver. This you can also take an analogy with the protic solvent or the protic acids. You remember how H2SO4 is a stronger acid, the HNO3, H2SO4, HCl, we used to see which acid will give its proton first. Similarly, it is similar analogy here also, that which element will give first its electron. This zinc is giving electron first as compared to copper and silver. Similarly, this H2SO4 we discussed HNO3, HCl. Same analogy, the acids and the metals giving the electrons and the acids giving the protons. Then we have discussed that this charge transfer, to this thinking about the charge, that whether the whether the charge is increasing or decreasing, it is very easy for us to understand in the case of ionic compounds, for example NaCl or HCl. But let us say there is a covalent compound H2O, CH4. Now we know that there has not been a complete transfer of electrons. Carbon is not C4 plus or hydrogen is not H minus. Okay, there has been a sharing of electrons. So, there is a problem for us to understand whether the charge is getting increasing or decreasing on which carbon, which element. So, for that a more practical concept came into the picture, that is oxidation number. What oxidation number is? That oxidation number assumes the complete transfer of electron, it does not assume the sharing of electrons, it just assumes that there has been a complete transfer of electrons. So, the complete transfer of electron, where the electron transfer will happen from? Oxidation number, complete transfer of electron. Complete transfer of electron. Now, electron transfer will occur from one place to another. So, where it will be from? The more, let us say electronegativity, we can classify it on. So, more electronegative atom like fluorine, oxygen, what will it happen? It will gain electron, lose electrons, it will gain electrons. So, there will be a complete transfer of electrons from a less electronegative element, to a more electronegative element. For example, let us discuss this reaction which I have discussed in the previous lecture, is this H2 plus O2 gives H2O. Okay. We know this charge on H2 0, O2 is 0. Okay, let me use a different color just for simplification. Now, in case of H2O, okay, which element is more electronegative? Oxygen is more electronegative. Oxygen is more electronegative. That means that the oxygen will gain electrons, that means oxygen will gain electrons. Oxygen will be in, or cell will be in negative charge. Okay. Hydrogen we know has only one electron, that means hydrogen is +1 and oxygen is -2. You see the overall charge should be balanced. How it will be balanced? Because there are two hydrogens corresponding for two positive charge, that has been balanced out, balanced by two negative charge that is why the formula is H2O. Formula is H2O because oxygen carries a charge of -2 and this -2 will be balanced by two hydrogens, because one hydrogen is one positive charge. So, formula goes to H2O, that means 2 H plus giving 2 electrons been gained by the one oxygen atom, and electron transfer has been occurred from a less electronegative element, that is hydrogen, to a more electronegative element, that is oxygen. Okay. Similarly, I have discussed one also this CH4. Okay. This carbon, there has been electron transfer from carbon to hydrogen, because carbon is more is less electronegative than hydrogen. So, carbon we say +4 and hydrogen we say -1. Okay. Now, you see that the hydrogen can be in -1 oxidation state also, hydrogen can be in +1 oxidation state also, depends with which the metal or with which the other element is, whether the other element is more electronegative or less electronegative. If hydrogen is attached with, let us say, halides, that means fluorine, chlorine, bromine, iodine, or let us say oxygen, nitrogen, then it will have what? It will have positive charge, right. Nitrogen it will have negative charge, and if it is attached to a less electronegative element, that is carbon, sodium, potassium, that means metals, if it have attached to them, then it will have a minus charge. Now, the thing is, how do we calculate the oxidation number? Now, this seems a bit problematic here, that when hydrogen will be in +1, -1. So, let us discuss how to calculate the oxidation number, or there are some how to calculate the oxidation number. There have been some certain rules for us to determine whether the whatever the oxidation state of an element is. Okay. Okay. Now, first of all, just to clarify the thing, oxidation number, this oxidation number is often just keep this thing in mind, the oxidation number and oxidation state are both are equal, both are same things, just people use this interchangeably. Oxidation number also means the same, oxidation state also means the same. Okay. Now, first discuss that we will discuss what oxidation number and how to calculate it. Oxidation number, if I will go by the definition, it denotes it means it oxidation number denotes the oxidation state of an element in a compound assigned according to the set of rules, assigned according to a set of rules formulated, these rules are formulated on the basis of what? On the basis, what basis? That electron pair in a covalent bond belongs entirely to okay. So, what oxidation number here we means? Oxidation number denotes the oxidation state, it denotes the oxidation state of an element in a compound assigned according to a set of rules. That rules we will discuss in the upcoming slides. That this oxidation number denotes the oxidation state of an element in a compound according to what? According to a set of rules. And how this set of rules have been formulated? The set of rules have been formulated on the basis what? That electron pair in a covalent bond belongs entirely to more electronegative element. That what happens is what when we say this carbon and hydrogen, there has been a sharing of electrons, right. What happens that carbon okay. Okay. This we form like a CH bond has been formed because there has been a sharing of 1 electron from both carbon and hydrogen, means total sharing of 2 electrons, and that is how it forms a CH bond. Okay. Now, we know that the more electronegative atom, that the element which has more electronegativity will push this electron pair will be pushed towards it. In actual what happens, this carbon is more electropositive and hydrogen is more electronegative. So, what happens is this electron pair in real, this electron pair is shifted towards this electron pair okay. When it what in actual happens is this electron pair, this sharing of electrons, this is shifted towards a more electronegative element. But when we discuss about the oxidation number, what oxidation number assumes is this electron pair completely denotes to the more electronegative element. That means this electron pair completely denotes to hydrogen in case of CH4, that means hydrogen carrying a minus charge and carbon is getting a positive charge. Okay. This you might have understood till now. This electron pair that has been shared okay. You see this electron pair is more shifted towards the hydrogen, but while discussing about the oxidation state, while discussing or oxidation number, what oxidation number assumes is this oxidation number assumes is this electron shifted completely to the hydrogen, it means carbon gets plus and hydrogen get 1 minus. Okay. This is an assumption for calculating oxidation number in covalent compounds. Okay. This we have to keep keep in mind. Now, this calculating oxidation number of this seems easy. Okay, CH4, this CH4, if I say CH4 total oxidation state. Okay, this carbon, let us say hydrogen is minus 1 because this is gaining electrons, more electronegative atom, minus 1. Carbon you say carbon is giving 1 electron to hydrogen, so it gets plus 1, right, but there are 4 hydrogens, that means its oxidation state is plus 4. Okay. Now, this seems simple, but there are several complex molecules and their oxidation state calculating it will get a bit difficult. So, there have been a certain rules that have been assigned, so that it becomes easy for us to calculate the oxidation state of any element in any compound. Let us discuss those rules for calculating rules for calculation of oxidation number. Okay. What the first rule is, Okay. What the first one is, in elements present in the free or uncombined state, each atom bears an oxidation number of 0. For example, I say H2, Cl2, Br2, okay, Na solid I am taking, magnesium. Okay. These are not combined with any other, or let us say hydrogen is combined with the hydrogen only, chlorine is combined with chlorine only, means they are present in the free state or not combined with any other element. On all of these elements, the oxidation state is, the oxidation number is what? 0. Okay. This H2 we know is comprised of H and H, okay. But there is been a equal sharing of electrons. Why in H2 the oxidation state is 0? Because you can say that I said it is an uncombined state, but this H2 is combined with another, this hydrogen is combined with another hydrogen. Now, what is this? Because I have told you that oxidation number, or calculating the oxidation number, but we assume that there has been complete electron transfer from a less electronegative element to more electronegative element. Now, in case of H2, both are hydrogens, that means both have same electronegativity, both have same electronegativity, both the hydrogens have same electronegativity, that means both the hydrogens carry a 0 oxidation state, both hydrogens have 0 oxidation state. Okay. Just this thing. Second rule is, for ions. For ions, the oxidation number is equal to charge on the ion. Let us say Na plus, for example, Na plus, Mg2 plus, or say Cl minus, or let us say sulfur 2 minus. So, this Na plus is oxidation number is what? Oxidation number plus 1, magnesium plus 2, because the charge on the ion will be same as the oxidation number of that element. For chlorine it is minus 1, for sulfur it is minus 2, charge is same, this charge is nothing but the oxidation number, but this is just in the case of ions. For the ions, the oxidation number is same as the charge on that ion. Okay. Let us say if I say alkali metals is what? Group 1. Group 1 metals are called alkali metals, for example, sodium, potassium, or let us go to the rubidium only, okay. Cesium, francium, let us not talk about it. Okay. So, the alkali metals, all the alkali metals, if they are present in ions, if they are present in ionic form, oxidation number is plus 1. Similarly, for group 2, for example, magnesium, the oxidation number is plus 2. That means, alkali metals always have oxidation state of what? Plus 1. Alkaline earth metals, that is group 2, always an oxidation number of plus 2, because that are the only number of electrons that it needs to share or need to transfer to get the octet complete, right. So, for alkali metals plus 1, for alkaline earth metal plus 2, or for ions, any ion, we say that the oxidation number is equal to the charge on that ion. There are few more rules that we will discuss in the next classes. Thank you.